Recording in progress.
Comes on everyone. Let's start off. Hope everyone has gone through the notes. So last thing we did was SHM. Okay, let's continue with this. So, like I said, last session we primarily focused, on the equations of SHM and stuff. So we have two particles. Oscillate in SHM along the same line. With the same mean position. So we have two particles that are oscillating along the same line in SHM with the same mean. Assume they do not collide each other, they'll just pass through. So one particle ka equation was x1 is a sine omega t. The second was a sine omega t plus 60 degrees. Meaning one is starting from the mean position and another is starting at some 60 degrees. So both are not at the, when you think of like this. So one guy is starting here. The first one is starting at t0 here. The second one is starting somewhere here. So as the green one is going like this, the red one will come like this. Then the green one will take a turn. In the meantime, the red will go ahead and they will meet somewhere here. You're getting how it is? So they are actually chasing each other. Now, since they pass through each other, they will meet for infinite times. So the first question, this is a standard model, a proper mains level question. You should definitely know how to do this. Find the time when they meet. Now, they can meet infinite times, right? So exam, they can ask like this also. Find the third time when they meet. So find all the times when they meet. Second, what is the maximum distance between them? When these two particles are moving on that line on SHM, at some point you'll get a maximum distance between them. Let's get these two. I hope the question was clear. If someone didn't get the diagram, didn't understand what the question, please ask me. You got an answer? You can type in the chat box here to the co-host. How do you do the first one? Think. I'll give you a minute. Two pi by omega. नहीं रे. Pi by 3 omega. Okay. Try to give an answer in terms of capital T, where omega is 2 pi by t. Let's see. Yeah, I think that looks right. Let me ask you one simple thing. If two particles have to meet, let's say if you and your friend have to meet, right? You decided to meet your friend. So what should be same? What should be same? What do you have to decide? Tell me one thing. If you and your friend are going to meet, what are the things you'll decide on? The place. If you are, if you are at your house and if your friend is at their house, are they meeting each other? You need to define a place, right? So you should be at the same place. But what if you go today and your friend comes tomorrow? Are you meeting then? So you should be at the same place at the same time. So that's it. The simple thing there. So if these two particles are meeting, the coordinate must be same at the same time. Since they meet, they must have same coordinate. So I can directly say x1 is equal to x2. So this will be a sine omega t. A sine omega t plus pi by 3. Now be careful. Don't write omega t is equal to this. If you remember from Max trigonometry equations, if you have sine theta is equal to sine alpha, the solution is theta is equal to n pi plus minus 1 whole power n alpha. This is the solution. Theta is not equal to alpha. I mean, that is one solution, but this is a more general solution. So omega t will be n pi plus minus 1 whole power n omega t plus pi by 3. So put n is equal to 0. If you put n is equal to 0, you'll get omega t is equal to omega t plus pi by 3. This thing t gets cancelled. This is an undefined solution. This is not valid. You are getting 0 is equal to pi by 3. Put n is equal to 1, we get omega t will be pi minus omega t plus pi by 3. This guy will be 2 omega t is equal to 2 pi by 3. Omega is 2 pi by capital T. We get t is equal to t by 6. This is the first time they meet. If you put n is equal to 2, again you'll get an invalid solution. N is equal to 3 will work again. So omega t will be 3 pi minus omega t plus pi by 3. Right, so this will be how much? 2 omega t, 339 minus 1, 8 pi by 3. Two pi, so we'll get 2t by 3. This is the second time they meet. N is equal to 4 will be again invalid, so on. So n is equal to 5 will be the third time they meet. So only the odd numbers work. So if they ask you find the third time when they meet, you can put n is equal to 5. So they will meet for infinite times. Is that making sense, everyone? The simple max there is no physics there, it's just max. What about the maximum distance? Yeah, some of you did get the answer. How do you get the maximum distance? Now, again, you can do x2 minus x1 and then do maximum minimum, but that goes quite long. There's a much better way to do it, visually. Aaron, clear with this page? right? Don't worry about the notes. I'll send you the PDF. So focus on listening and understanding and solve the questions. So how do you find the maximum distance? Now look at this. Initially, when the circle is here, think of it like this. We're actually studying the shadow of the two particles which are oscillating in SHM. So one guy is here, one whose shadow is somewhere here. The other guy is somewhere here, whose shadow is somewhere here. So I'll take a more general case. Let x1 be a sine omega t plus phi 1 and x2 be a sine omega t plus phi 2. Let this angle be phi, where phi is phi 1 minus phi 2. Now, when you drop the shadow here, what is the distance between them? The distance between them is this, isn't it? When I say the distance between the two particles, what you're looking at is the projections or the shadows on the x-axis. That is the distance between them. This is the distance between the particles. Now, do remember, this is going with omega. The other one is also going with omega, meaning no matter how much you rotate, the angle phi will always remain same. After some time, when this thing rotates, let's say one comes somewhere here, and let's say two comes somewhere here. Now, if you try to drop the shadow, this is two, this is one. Now the distance between them will be this. Now, using this logic, can you tell me when will this distance be maximum? So as these two things are continuously rotating, can you tell me there is a particular position when this distance has to be maximum? You will notice this distance will come maximum when 1 and this particle 2 are symmetrical about the y-axis. When they're exactly horizontal like this, isn't this the maximum distance between them? Where this angle will be phi by 2 and this angle will be phi by 2. Check it out. You take any other position, it will be always lesser than this distance. Because the moment when they move, you can see it is shrinking. The distance is smaller, it becomes even smaller. So when both the particles are making equal angles with the y-axis, you get the maximum distance. And this thing will be how much? A sine phi by 2. This distance also will be a sine phi by 2. It's an isosceles triangle. Meaning you could have got the same thing at the bottom also. You could have got one here. You could have got two here. So there are two positions when this maximum distance will occur. So max distance occurs when particles are on either side of y-axis symmetrically. So what is the maximum distance here? You want to make the maximum distance as radius, then change the angle, right? So there, you can remember the result. Examiner, you won't have time to derive this. This will be 2a sine phi by 2. And phi is nothing but modulus phi 1 minus phi 2, whichever is a bigger angle. There, we didn't prove this mathematically, but we proved this visually. Quite a useful result. This is the kind of question you'll get in mains orbits. Straightforward question. If you know the result, it will take barely 10 seconds, or else you will struggle to figure out what is the maximum distance between them. So in our question here, phi is how much? 60 degrees. So that will be 2a sine 30, that is a. Clear, everyone? So depending on what position you start, the maximum distance does change. Everyone clear with this? Next one. The next one is important. But first, let's do an easy one, and then I'll give you a more general solution for this. Let's say if I have something like pi sine omega t plus phi root 3 cos omega t. So sometimes functions will be given like this. Find amplitude and phase angle. If the symmetric about y-axis, they're meeting now, right, Daksha? And the shadows will meet. That will be the minimum distance, isn't it? Understand, here what you're studying, the two particles are going in a circle, and what you're studying is the shadows. Yeah, this was easy. This is more of a max question again. Amplitude 10 and phase angle is 60. Yeah. Try. Others try. I'll give another 30 seconds. This was easy. Let's say. So the problem is we know our general equation is in the form of a sine omega t plus phi. This thing doesn't look like that. So your job is to convert it. So take out phi common, multiply half sine omega t, root 3 by 2 cos omega t, multiply into 2. This becomes 10, and this can be written as that is the cos 60 and that is sine 60. This will be sine omega t plus phi by 3. There, you're done. So this is your amplitude. This is your phase angle. So this was easy. This is a typical means level question. But what happens if there are more than two functions? Then you can't do this that easily every time. So we have a method called phasors. This comes from a complex numbers, right? We will not get into why and what. I'll give you a little brief, but this concept is from complex numbers and quite useful one. Comes in 4 chapters: SHM, waves, wave optics, and alternating current. So listen carefully to this thing. Everyone clear with this page? Any doubts on this? Pratik, Soham, Surya? Clear? So in phasors, right, what we do, so it's a way to add sine functions and cos functions. In phasors, we treat amplitude as the magnitude of a vector at an angle phi, which is the phase angle. Now, what do you mean by that? For example, say, if I take a more general thing, x is equal to a sine omega t plus b sine omega t plus phi, right? Now ask yourself, again, going back to our analogy of a circle, this equation, what it is telling you is simply there are two circles, two concentric circles. We have one particle here going with amplitude A, and we have another particle here going with the amplitude V, and the angle between them is phi. Now, don't forget, this guy is going with omega, this guy is also going with omega. Now, tell me one thing, no matter how long they rotate, will the angle between them change? If the two particles go with the same omega, the angle will always remain same. So, if you actually look at the resultant itself will be going on another new circle. Isn't it? So if I take the resultant of these two vectors, you will get a resultant which is also rotating with the same omega in a new circle of a different radius. Is that making sense? So using that analogy, what I can do, look at here. So this thing is A, angle is 0. I can write this thing as A, phase angle is 0 here. It's a vector. This is B, angle phi. So I'll treat this as another vector, B at an angle phi. Then you can treat them like a vector. So the horizontal component will be A plus B cos phi. The vertical component will be B sin phi. This would be the resultant at an angle alpha. And we get the resultant will be root over. You can square them and add them. It will be a square plus b square. It's actually parallelogram law of vectors. 2ab cos phi. And that angle tan alpha will be b sin phi plus a plus b cos phi. And then you can write this solution as, so your equation becomes like this. X is equal to r sine omega t plus alpha. So this equation, which you have x is a sine omega t, can be written like this, where r is your amplitude, alpha is your phase angle. So look at this thing. So if I try to solve this using phasors, so 5 sine omega t. So we have one vector with 5. Another vector is 5 root 3 cos omega t. So I have to write that as a, let me write that in terms of sine. So this can be written as x is equal to 5 sine omega t. Remember, always keep omega positive. So you can write 90 minus theta also, but that will make omega negative. So this will be 5 root 3 sine omega t plus 90. So look at the vectors. This is 5. This guy is 5 root 3. This is the resultant, which is 10, and this angle is 60 there. So directly you can say x is equal to 10 sine omega t plus 60. This was still easy because there are only two functions. And I gave pretty good numbers. You will not be so lucky every time. But is this concept clear, everyone, with the phasors? You can treat them, the amplitudes as vectors and the phase angle as an angle made with the x-axis. I can do this even if there are 10 vectors. There's only one condition. This is valid only for same omega. If omegas are different, you can't do this. That is the only limitation here. You can use this anywhere. You can have 100 sine functions and you can still use this and work it out. But are you getting a basic idea why this is working out from the picture? But the actual concept, right, goes from phasors. So that comes in complex numbers if you have done something like that. Clear? Let's see a question. Let's see a question. So if I have x is equal to 20 sine omega t plus 20 root 2 sine omega t plus 45 plus 20 cos omega t plus 25 sine omega t plus 37. Now you can't use that, multiply, divide, and that thing. It won't work. Find amplitude. Let's get this. More of a max question, like I said, it's all vectors. Any answers? So there are like 4 vectors now. 7, 8, 2, 5. Nah, it's not 7, 8, 2, 5. Let's see. 55 square, 60 square, yeah, something like that you'll get. So this 20 cos omega t is nothing but 20 sine omega t plus 90. Yeah, you got an answer, you can type in the chat box here. The co-host. So yeah, so if you put this first vector, how much is that? So horizontally we have this is 20. The second vector is 20 root 2 at 45 degrees. 20 root 2, 45. Third vector 20 at 90 degrees. So this is 20. Next vector is 25, making an angle of 37 degrees. So these are the 4 vectors. Root 6625. Now resolve them into components. So horizontal component will be 20 plus 25 cos 37 plus 20 root 2 cos 45. Vertically, you'll have 20 root 2 sine 37 plus 25 sine, no wait, 25 sine 45, 25 sine 37. How much is this? 20 root 2 cos 45 is also 20. 20 cos 37 is 4 by 5. This guy is 60. This guy is 55. You're done. So this would be your resultant R, which is root over 55 square plus 60 square. And this is your angle alpha, which is tan inverse 55 by 60. So you can write the equation x is equal to r sine omega t plus alpha. It doesn't matter how many functions you have, you can always do this. It works out. Clear, everyone? So that's your amplitude 55 square plus 60 square. So this method is pretty cool. Saves you a lot of time. If you try to do this in a general mathematical form, you will get it, but it will be quite a mess. Unfortunately, HSMA, the proof they're asking, you have HSMA derivation is there for this one. And you literally have to expand that sine omega t plus 5 expand करके we have to take common, we have to do a lot of nonsense. That is HSC boards में है, but ठीक है, entrance के लिए we don't need it right now. Phasors. So remember this word phasors. When I say phasors, you should know, okay, I can treat it as a vector and I can solve. This will come in 4 chapters, including SHM. Quite a useful concept. Clear, everyone? Arnav, clear with this? Any doubts on this? Parth? Clear? Falak? Clear with this? Devansh? Daksha? Vignajit? Rehan? Sharman? Clear? Next one. Now, if you observe here, everything was X only. But what if even SHMs, right? You can have something like vector form. So suppose someone gives you like this, R bar is equal to A sine omega t I cap, B sine omega t j cap. Or R bar is equal to A sine omega t I cap, B cos omega t j cap. Something like this. So if you give an equation like this, so how can you get equations like this? These are possible when, let's say, if you have a spring and block, and you have one more spring here, two springs perpendicular to each other. So this spring is pushing in the x direction, this spring is pushing in the y direction. You're getting how the motion is? So you're actually including two SHMs perpendicular to each other. If these were the equations, find amplitude. So find amplitude, and can you draw the path of the particle? What is the shape in which the particle goes? So this is called superposition. If you superpose two SHMs on the particle. So when you're in electrical engineering, right, you will have something called an oscilloscope. You can do that. We can do this with actually currents and voltages rather than springs, but okay. So you can superpose SHMs. And when you're in first year, right, in IIT, you learn something called a Fourier series. So the basic theme is this: you can represent any function using only sines. So it's a pretty useful thing. So using your sinusoidal sources and all, you can create any function, mathematical functions in a computer. So if you tell your computer draw y is equal to x line, it won't understand what is equal to y is equal to x. It tries to superpose sine functions and gets y is equal to x. So there is something of that sort. Yeah, first was easy. Can you tell me the trajectory also, how it looks? Think, I'll give a minute. It's not a parabola, right? It's parabola. Let's see. Look at the first one. So indirectly, if you think about this, this is your x coordinate. This is your y coordinate. So don't see both together, just separate them out. So we have x is equal to a sine omega t. Y is also equal to b sine omega t. So if you just divide them, you will end up with x by y is equal to a by b. This is an equation of a straight line. Y is equal to b by a into x. Meaning both the springs are in sync. This is how it is going. So the maximum distance will be, the maximum x coordinate is a, maximum y coordinate is b. So the maximum distance it goes, again, understand the definition of amplitude. The maximum distance from the mean position, which is root over a square plus b square. That's your amplitude. So from the mean position, this will travel the maximum distance root over a square plus b square. And the trajectory is a line. Now what about b? Understood, this is what you do. You just get x and y coordinates from there and you try to figure out what is the relation between them. Get the second one? Right, Vihan. Right path. Try. What about the second one? I'll give you a minute. Yeah, it's an ellipse. X is equal to a sine omega t, y is equal to b cos omega t. If you square them, x square by a square plus y square by b square becomes equal to 1. This is an ellipse. If a is equal to b, it becomes a circle. So here, if you look at the trajectory here, x coordinate is at the mean position, whereas a y coordinate is at extreme position. Look at this, at t is equal to 0, y is already maximum, meaning somewhere mean position is here. This guy is here. This is how the ellipse is. You're getting it? It is starting from the top of the ellipse. So this is how the motion would something look like. Now here, what is the amplitude? The maximum distance. Now we don't know which one is bigger. So this length was B and this length was A. So amplitude will be A or B, whichever is bigger. Clear, everyone? Generally, till here you can handle it, okay? If you look at the phase angle between these two was 90. Here, the phase angle between them was 0. So 0 and 90 are fine, but if you suddenly get 45 or something, things start getting messed up. Now, we don't have that in the portion, but they would look something like this. But everyone clear with this page? Any doubts on this? Sahana, Abhinav, Adi, Arush? Arush, adjust your camera a bit, can't see you. Make sure your faces are completely visible on the screen, everyone. Surya. So, there, look at this. So, if you have a general equation like this, R bar is equal to A sine omega t I cap plus B sine omega t plus phi. Now here you can change the value of phi. You can also change the value of AB. So this is A is to B. Look at this. A is equal to B is equal to 1. This is the phase angle phi. So if you have A is equal to B and phi is equal to 0, you get a straight line. If A is equal to B and phi is equal to 45, you get an ellipse. If A is equal to B and angle 90, you get a circle. So we have actually done these two cases. And ellipse also, we could have done circle, and yeah, we could have got an ellipse also. Where is that? Some shape. So circle, ellipse, and all this stuff. Now look at the other one. So this is 1:2 ratio, and these are the angles. Now we don't have in the portion, just for your idea there. We can get all these kind of weird shapes. You can't replicate them with springs. We actually use voltage signals. You can create two different voltage sources and superpose them. You get all these things. We did this thing in IIT mein, second year lab. We did these things. So these things are called Lissajous figures. So in our lab, what they did, right? The teacher gave us some capacitors, resistance circuits, and everything. And the homework was this: we need to get this shape. And we had around 2.5 hours to get that shape. So I was doing, and I got this shape. And I was so happy. I was showing everyone, Diko, what I got, what I got. I wasted all the time. Time got over. Teacher came and scolded everyone who didn't complete. Then I had to go next day extra class for 2 hours, and then I had to complete it. So yeah, you can get all these kind of weird shapes. So next time when you're having a Rangoli competition in your society and you don't know what to draw, let's draw figures. So they're quite helpful. Clear with us? So this is just for an idea. Don't worry too much about this. But mathematically, we can solve only these two cases so far. Next one. So great. So that is all about the motion and all that stuff. Next thing, if you're moving, then you'll also have energy. So this is another important one. Energy of SHM. So whatever we did last class and today, right? All these things, if you see, like I said, SHM, we can divide into three parts. The mathematical part, that's what we are doing. If you see it's all equation, it looks more like max. These things is important because the same things will repeat again in waves. So this is the basis there. So energy of an SHM. The first thing, kinetic energy, straightforward formula, half mv square. But we know velocity is equal to half m omega square a square minus x square. Next thing, we know force is equal to minus du by dx. This comes from work per energy. And we know force is equal to minus kx. So we get du is equal to kx. Dx integrate on both sides. This will be u mean. This will be x mean. If you take x mean as 0 to x, and this is u. When I integrate this, you end up with u minus u mean is equal to half kx square. So the potential energy U is given by, now remember again, omega square is equal to K by M. So I can write K is equal to M omega square. This will be M omega square x square plus U mean. So this is your kinetic energy ka term. You need to remember this stuff. This is the potential energy ka term. So in books, right, normally you will see only this part. People ignore U mean here. Getting it? So the U mean people take it as 0 and solve. Maybe CET mains level tak theek hai, but that will actually create problems. I'll show you. So this is your potential energy. So if I add these two functions, I'll get total energy is potential plus kinetic energy. You will notice the x square ka term cancels out. You end up with half m omega square a square plus u mean. So the total energy is half m omega square a square plus u mean, which is constant, but this term which we are getting, right, half m omega square a square, this is called oscillation energy. We will talk about that in the next page. So total energy of SHM is different from oscillation energy of SHM. Both are completely two different terms. So exam they'll ask you what is oscillation energy, and people will let total energy and come. We will see what is oscillation energy, but have a look at this thing. Clear? Now, so what is oscillation energy? So oscillation energy is given by half m omega square a square, and if you remember, a omega is Vmax. So this is half m Vmax square, which is also maximum kinetic energy. Because we know Vmax is a omega. So what does this mean actually? So this is the energy which converts from potential. So when this guy is oscillating, the spring is elongating, compressing, right, and speed is increasing, becomes potential to kinetic, kinetic to potential, and so on. So it oscillates between potential and kinetic. So what do you mean by this is an analogy? Think of like this. Let's say in your bank account you have 1 lakh rupees, but bank ka minimum balance is 10,000, right? So you have to maintain a 10,000 rupees minimum balance, or else your account will get closed or whatever. So if I ask you this question, how much money do you have? 1 lakh. How much is actually usable? 90,000. Is it making sense? Your total energy is not the oscillation energy. Not necessary every time. If your U mean is zero, then it is. So that means if you see the oscillation energy is the part which actually converts from kinetic to potential and potential to kinetic. It's not necessary that total energy will become into oscillation energy. You will see a question on that. Getting this? So total energy and oscillation energy need not be equal, or they will be equal if U mean is zero. But remember this thing, oscillation energy is completely different term. Something like in fluid mechanics we did, the force due to a liquid and Bion's force due to liquid are not same, isn't it? So be careful like that. This thing is especially an advanced one. Huh? They'll ask you oscillation energy in more than one choice questions. If U mean is zero. Now if you try to plot a graph, can you tell me which line is which one is total energy, which one is kinetic energy, which one is potential energy? Which one is what? What is the black one? Black one, total energy is constant, isn't it? So black one is total energy. Tell me one thing. At extreme position, what is your velocity? At extreme position, what is your velocity? Zero. That means kinetic energy must be zero at extreme position. So the red one is zero. So that's your kinetic energy. At extreme position, spring is maximum elongated. So potential energy must be maximum. So green is potential, right? Red is kinetic energy. But you can also see from mathematical functions. If you see the potential energy, this is y is equal to x square. It's a upper parabola. This is a downward parabola. But this is the case when u mean is zero. So this is the graph which you look in all books and everything. But sometimes you will get a graph. What if u mean is not zero? If u mean is greater than zero, how do you think the graph will look? U mean is less than zero. Then graphs will look like this. Interestingly, the kinetic energy will remain same. The potential energy will become like this. So this will be a little elevated here. So u mean is not zero. So in case you see graphs like this, don't think them they're wrong. You can have graphs like this. So this indicates if your u mean ka value changes, the total energy and the potential energy will shift. But this is the most standard graph you'll see in all the books. No, that's the problem mains question, which is what. But in case you see this also, don't think it is wrong. Any doubts on this? Clear? So if you see all these graphs are with respect to x, the position. So you can also have graphs with respect to time. Can I go ahead? Any doubts on this? Next one. I'll send you the PDF, so don't worry about it. You can put on the main points. So if you put the thing, so we know x is equal to a sine omega t, and the velocity will be a omega dx by dt. Which is a omega cos omega t. So we get kinetic energy will be half m omega square a square cos square omega t. Potential energy will be half m omega square a square sine square omega t. So if you add them, you'll get a constant value. And if you plot this graph, potential energy versus time. So the previous ones were position graphs. These are time graphs. In SHM, you'll always have two types of graphs with respect to position, with respect to time. We have done this with even x, a, and velocity also. Do check it out. So cos square graph. So potential is sine square. It looks like this. This thing is cos square. Something like this. Clear, everyone? And if you see these functions, right, repeat after every t by 2. The periodicity has become half. So this was an important question they'll ask you. Huh? If the frequency of oscillation is f, what is the frequency of energy oscillation? Tell me one thing. In one oscillation, how many times do you get maximum speed? Two times, right? You cross the mean position two times. That means your kinetic energy is coming to the same value in half of the time period. Isn't that the meaning of periodicity? The function should repeat itself after a certain time interval. The motion will take full time t, whereas your kinetic energy takes only half the time. So if the frequency of oscillation is f, then the frequency of energy oscillation is 2f. That was one. Second thing, they can ask you, what is the average potential energy and average kinetic energy in SHM? So average potential energy is equal to average kinetic energy will be 1 by 4 m omega square a square. How did we get this? Again, this is more of a max thing. If you take an average value of a sine function, average of sine square theta, so this is how we do this. Integral sine square theta d theta from 0 to 2 pi by integral d theta from 0 to 2 pi. You can check it out, you'll get it half. So the average of sine square and cos square is half. Average of cos square theta is also half. These are two kind of questions they can ask you at a mains level or even in advanced में more than one choice questions में one statement. So if a particle oscillates 100 times per second, the energy oscillates 200 times. The average value is this. There, have a look at this. Let's see a question on this. Any doubts on this page? Let's see. Let me show you a question on this. We have potential energy U of x is equal to x square minus 14x plus 50. This is the potential energy as function of x coordinate. Mass of the body is 2 kg. Total energy is 50 joules. This much information we have. Find omega, find x mean, find time period, find amplitude, find maximum speed, find oscillation energy, find u mean, find the coordinates of extreme positions. So when this thing oscillates, what are the coordinates of extreme positions? Get them all. Kind of all are related to each other. They could ask anything, one or two things in the exam. This is what I was saying. You will get a question like this, find oscillation energy, and people will have no clue what is that meaning. And people think it's total energy. So be careful with that. Once you know the total energy and oscillation energy are two different things, it is understood. Let's give it a try. How do we start? Okay, most people did get the mean. You mean, yeah. Let's see. How do we start? First of all, is there any relation between force and potential energy? There is. So we know F is equal to minus du by dx. So once you do this, you'll get minus of 2x minus 14. And we know force is equal to mass into acceleration. So 2 into A is minus 2 into x minus 7. So we get A is equal to minus 1 into x minus 7. So if you look at this with our general equation A is equal to minus omega square x minus x mean. There you can compare here. So omega is 1. So from there you get the time period 2 pi by omega, which is 2 pi. And x mean is equal to 7. Once you got x mean, you'll get u mean also. So u mean will be when x is equal to 7, that's 7 square minus 14 into 7 plus 50. This is 1 joule. Look at the meaning of this. U mean is 1 joule, meaning this is not recoverable. No matter what you do, you can't extract this energy from total. So we know total energy will be half m omega square a square plus u mean. This is your oscillation energy. So out of 50, you can only convert 49 into kinetic and kinetic into potential. So oscillation energy is 49 joules. Is that making sense, everyone? V max is a omega. So even from here, you could have figured it out. Is I can calculate from here. So this guy will be half. Mass is 2. Omega square is 1 square and a square is 49. So amplitude is 7. I got everything. What else do I need? Oscillation energy. V mean is also V max is a omega. That is also 7. So if you look at the positions here, this is how it is looking. So when this block is oscillating, this was the mean position. Now every time mean position need not be origin. X is equal to 7 is mean. So from the mean position, you're going to the extreme position. Amplitude is how much? 7. So x is equal to 14 is extreme. Another extreme is x is equal to 0. So this particle is actually oscillating between 0 to 14 and 7 is the extreme position. 7 is the mean position. Is this making sense? So general tendency, right? We take always mean position as origin, but it is not necessary. Your coordinates is up to you. You can choose whatever axis you want, whichever point as origin. Is this making sense, everyone? You know, we have seen something similar before. You know where? Anyone remembers that? In work per energy, this question, yeah. Can you find the oscillation energy of this? Just do it roughly. Like, I'll give you a minute. We have done this in work per energy. Look at this. I'll just ask you one thing. See, if kinetic energy is maximum, does it mean potential energy is 0? That is a catch. When kinetic energy is maximum, potential energy is minimum. That minimum need not be 0. That was a mistake people do actually. So let's get this, find the oscillation energy for this. Try, I'll give you a minute. So I can create any type of function u of x and I can ask you oscillation energy. So we did this in work per energy. There we couldn't find time and all, but now you can find that also additional. Got this. So look at this thing. So when do we get? So we know oscillation energy is what? Half m v max squared, the maximum kinetic energy. So I need to find maximum speed. So when you differentiate this, I got the minimum value is minus 1/4. See, this was the catch. The most common mistake, right? People think kinetic energy is maximum and potential energy is zero. Potential energy should be minimum, and that minimum value is actually minus 1/4. So here actually U mean is minus 1/4. You can extract more than total energy. So we get the maximum kinetic energy is 9/4. So this is the oscillation energy, everyone. 9/4. Clear, everyone? Right, Poroja? Getting what we did? We have to find the minimum value of U. How do you find a minimum of a function? Differentiate. First differential. But we got two roots, so I had to check for second differential, and then I found x is equal to 1 is a minima. So I substitute x is equal to 1. I got the minimum value is minus 1/4. Total is U minimum plus kinetic. I got the maximum speed. And oscillation energy is maximum kinetic energy, isn't it? So I'll get everything from here. So there are two positions here. Now I don't know which one is an equilibrium position. So stable equilibrium. X is equal to 1 and x is equal to minus 1. I think if you take x is equal to minus 1, you still get the same, I suppose. Yeah, you still get the same. So there are two minimas actually. Clear with this? It's a good one. There. So questions can be framed. We have seen something like this in work per energy. There. So that is a bit about energy, the functions, and all that stuff. That is the first part of it. So whatever we did so far, if you see, this is more mathematically oriented. And the same things will repeat again in waves starting and everything. So make sure to go through this stuff. It's important. It's even though mathematically there. The second part is physical systems. Now, if you have a springs and blocks and stuff, and we want to find the time period. Now, before going ahead, like every time we do, we have some general steps. So how do we find time period of a system? So this is the steps. So finding time period. You follow the steps, things will come. See, whenever you're learning something, always prefer to keep it in terms of certain steps, like an algorithm. Just imagine you're writing a program for a computer. The reason when you know what steps to follow a particular thing, when you make steps for anything, see, if you're learning to how to cook, make steps. Step 1, I'll put the vessel. Step 2, I should switch it on, put oil. Step 3, that. Step 4, this, whatever it is. You're planning to go for dance, that is also, there's a particular step. Step 1, I'll warm up, I'll do this, I'll do this, I'll do this, I'll do this. The reason for this, it's not that you're, mugging up or bahad kar rahe ho. When you have steps, and when something changes in the problem, you know which step is getting affected, and then you can adjust for it. But when you don't have a process and you're doing everything on your, at that moment, whatever you felt you did, and when there is a problem, you won't understand how to handle it. It is important to have steps. You go to an operation theater. In the operation theater, there is one nurse. You know what is her job? Every piece of equipment they used, she makes a checklist. Meaning, for example, the doctor is doing the surgery. He says, give me the scissor. She will write scissor taken. Now, her job is to make sure, did it come back or not? Right? The doctor says, give me cotton. Cotton, she will write one piece. The doctor has more cotton. Cotton second piece. Cotton 3 piece. Cotton 4. Cotton 5. Cotton 26. Now, her job in the end is to make sure everything is came back. She finds one piece is missing. Until that piece is found, the surgery, right? No one gets out of the room. That is how they make sure you don't leave any, your cotton or anything in the patient tummy after surgery. People used to do that. It is a pretty common thing. Getting it after doing so much blood is there everywhere. People can't see the cotton. It is drenched with blood. It is stuck inside. And there were cases where doctors have left scissors in the, after the operation. So people were dying unnecessarily. Then, some guy came up with an idea, boss, we need to make a checklist. And there is a second reason. After the surgery, first, unfortunately, for some reason, the patient dies. There will be an inquiry, right? And they want to be sure that there's like a fail-proof method. Like we did everything to the process, nothing was wrong from our side. It didn't work out. There are two reasons for that. One, if there's a problem, we can use that knowledge and do better next time. Second, boss, it is very difficult, when you're a doctor and the patient dies after you do surgery, mentally you get very affected, isn't it? It puts a lot of, stress on your mind that you killed someone. But when you know you did everything right, but unfortunately the patient didn't survive, at least you'll have that mental peace you did your best. So always keep this in mind. It is important. I'm not talking about physics. Tomorrow, no matter what you do in life, remember this thing. If you can make something into an algo, it works great. Even your own life. Morning, I wake up. Your life works like an algo only if you don't realize it. You wake up, you get up from the bed, you go straight into the washroom, you brush. There's a particular steps you follow every day. That's the reason I keep telling to send reports. People who don't have a proper routine, you do whatever you want every day, and your whole day go for the toss. Make a routine. If you want efficiency, you need to have a steps. So how do you find time period for this thing? First thing, choose your system. If you have a system and it's oscillating or anything, first choose which system are you studying, and then bring it to rest. It doesn't matter whether it is oscillating or doing anything, just bring it to rest at mean position. So if you bring it at mean position, it will be at rest there. It won't move because it's an equilibrium position. So every problem, whenever they ask you find time period, first bring it to rest and keep it in equilibrium. Second, after bringing it to equilibrium, displace it along stable equilibrium by x. Now, this is important. You cannot displace it however you want. And I hope you remember what is stable equilibrium, but let me give an example. For example, if I take a plus q charge and a plus q charge, right, and these are fixed. Now, along the bisector, if you keep a minus q charge, see what happens. This guy will attract, this guy will attract. The force will be towards the mean position. So if I push it up, it comes down, right? Similarly, if I push it down, it attracts this way, it attracts this way, it comes back. So this is a stable equilibrium. That is how we define an stable equilibrium. If you displace it, the force should be in the opposite direction. The particle will always try to come back there, it oscillates. The same question, plus q and plus q, but if you keep the minus q in the center and if you push it to the right, what do you think will happen? If you push it to the right, what do you think will happen? The moment you get closer to the right charge, this charge will attract more strongly than this charge, isn't it? If you push it to the right charge attracts more strongly than the left charge. What will happen? It won't come back. It will go and stick to the plus q on the right, isn't it? This will not come back. This is an unstable equilibrium. This will not do SHM. This is an unstable equilibrium. Did you see? Same position, depending on which way you push, it can be stable or unstable equilibrium. So perpendicular bisector is stable equilibrium. Along the line joining charges is unstable equilibrium. So here, if you see, when pushed towards right, the force due to right charge is more than left charge. It never comes back. Is that clear, everyone? Meaning, if I have to show you another example, see, this thing here didn't again work per energy, if you remember. Remember this thing, Pringles? A hyperboloid paraboloid. Look at the shape. If you keep the particle here and if you oscillate like this is stable equilibrium. But that same position, if you displace it like this is an unstable equilibrium. So this position can be both stable and unstable depending on which way you're displacing it. Hope you remember the shape we discussed in work per energy there. This is your Pringles basically. Clear? So step one, choose your time system and bring it to a trusted mean position. Second one, displace during stable equilibrium. Third point, so after displacing it, you will generate some forces. So find acceleration as function of x. Fourth point, compare it with a is equal to minus omega square x minus x mean. And then from here, we'll get time period is equal to 2 pi by omega. So we will see some examples. So if you see the whole chapter right again, the whole question will belong to some other chapter. In the end, SHM will come and hijack the problem and say this is SHM. Right? You will see. So we can use different sets there and everything. Everyone clear with the steps? Any doubts on this? The steps are important. Let me give you any problem. These are the steps. You can take any model. This will work. Okay. Take a break. Come back by 7 o'clock. We'll continue from here again. Any doubts so far? Take a break. Come back in 10 minutes. So let's see an example. So let's take a simple one. So if we have a block here, mass m, spring constant k, this is your mean position. So step one, choose your system. My block is my system. Step two, put it in mean position. There I kept it in mean position, then displace it by x. So you can compress this or elongate this. You can do both. I will elongate it. So let this thing go by x. Now here we have a convention. If you displace x, then you also take acceleration along x. Getting it? So that's the convention there. So now if you draw the FBD of this, the forces will be k into x. And this will be the acceleration. So this is more of a mathematical convention. Since the displacement is forward, we'll also assume acceleration is forward, and from there we'll try to proceed. We always choose acceleration in the direction of x. Science will take care of it. Then Newton's second law, net force is equal to mass into acceleration, kx is equal to mass into acceleration. Then we get A is equal to minus k by m into x. Then SHM will come and say, oh, this is looking like A is equal to minus omega square x. Therefore, omega is root over k by m, and the time period is 2 pi root over m by q. And interestingly, if you notice this is independent of x. Whether you pull the spring by 1 centimeter or 1 meter, it doesn't matter. The time taken is same. So the time period for a spring block system depends only on the mass and the spring constant. It doesn't depend on how much you have pulled it. Clear, everyone? So, meaning, think of like this. If you pull it only 1 centimeter, the force is so slow, meaning force is so less, it will come slowly. If you pull it too much, 1 meter, then the force is so high, it will move faster. The time taken will remain same. Clear with this? Let's take one more example. But this is the steps. Keep it in equilibrium, displace, and then see what happens. Going ahead, let's take one more example. Same thing if I take spring block, but let's take vertical now. So this is m, this is k. Now be careful here. This is the natural length. So natural length need not be the mean position every time. This is your mean. You can see clearly here, u mean is not 0 here. Isn't it? The spring is already stretched by some amount. So u mean is not 0. Anyways, so that we're not interested right now. So this is y. So if you draw the FBD, so we have the force ky is equal to mg. So initially it is in equilibrium. So ky is equal to mg. Step 1, choose your system. Block is my system. Step 2, displace it from equilibrium. So from here, I will displace it from equilibrium mass m. So I displaced it by x. And this thing is already stretched by y. Now draw the FBD. So the forces will be k into x plus y. Remember, the force should be, x is always measured from the natural length. This is mg. Forces will be on the block. Accelerations will be outside of the block. So keep them like that. We had this is all NLM. Then the forces will be mg minus kx minus ky is equal to mass into acceleration. But I know ky is equal to mg. I get a is equal to minus k by m into x. Now SHM will come and hijack the problem and say, oh, this is looking like a is equal to minus omega square x. The time period is 2 pi root over m by q. So for a spring block system, it doesn't matter if you keep it vertically or horizontally, the time period is same. It doesn't depend on what is your initial elongation. Is this making sense, everyone? Let's take one more example. Let's take from some other chapter instead of spring. Suppose if you have liquid, let the density of the liquid be rho L. And let's say we kept a cube inside. Side L. Density of the block is rho B. And initially it is already this much inside the liquid by Y. Now, if you push the block slightly inside, now again, I'm saying slightly because if you push too much, it will go completely into the water. I don't want that situation. Block is slightly pushed inside and released, find time period. So this could be a question. We are doing it as an example. I'll give you one more anyways. So there is no spring, nothing. You can still follow the process. Step 1, choose your system. My block is the system. Draw the FBD. So initially this much is inside the liquid. This is Y. This is L. This is L. What are the forces acting on the body? The bind force, FB, will be rho liquid, the volume displaced, which is Y into L square into G. The weight of the block, mg. So I get the bind force FB, rho liquid, Y, L square, G is equal to mg. This is an equilibrium position. Step 2, displace the body by x. So initially this was already Y. On top of it, you pushed it further x. So now the new bind force, I'll call it FB new. This will be rho liquid, x plus y, that's the total depth into L square into G. mg, acceleration. Newton's second law. If you see, there is no SHM so far. This is pure an LM question with a bind force there. So this would be mg minus rho liquid x plus y L square G is equal to mass into acceleration. You will notice this y ka term and mg ka term will cancel. You are left with minus rho liquid L square G into x. Mass of the body is rho body L cube into A. We get A is equal to minus rho liquid G by rho body into L into X. Now SHM will come and hijack the problem. This will say, oh, this is looking like A is equal to minus omega square X. So this is your omega square. So we have omega is equal to root over rho liquid G by rho body into L. Therefore, the time period is 2 pi by omega 2 by root over rho body L by rho liquid G. Again, if you notice the same thing, it doesn't depend on X. Are you getting how we did this? The steps, you follow the steps, you will get it. It doesn't matter. You have a spring block, you have liquid, you have thermodynamics. I will see a question on thermo also later on. Like anything, this is the catch. You follow the steps, you will get it any method. But this is going little long. We can eliminate one step here. Let me show that on the next page. But grasp this, understand what we're doing. Any doubts on this? Anyone not convinced with this? Any confusion? What happened? Anything that you're not clear, please ask. Clear? Now, here, if you notice something, right? This mg ka term and this y ka term is always cancelling out, isn't it? And it makes sense also. Think about it. Let's say if your body is in equilibrium, let's say you're applying force 10 and force 10, it is in equilibrium. Now, when you displace it, this force became 10 plus 1, right? And what you're doing now, you're saying 11 minus 10 is equal to ma. Now, what I am suggesting, how much did it change here? 0. How much did it change here? 1. So 1 minus 0 is ma, right? So what I'm actually interested is not the force, but the change in forces, isn't it? When you displace it, I'm interested how much is the force changing. So no, this is something, not a conceptual thing. You will not find in books and all. You might find, but this is not an official thing. So we will call it FBD of change in forces. So when I noticed, right, every time it is canceling out, I said, yeah, then we can eliminate one step. It saves you time. So FBD of change in forces. So in this, what we do, if a body is in equilibrium, and when you displace it, the net change in force is the restoring force. Let me take an example. So this question, which we have done already, so the block is here, M. This was the natural length. This was the mean. So I don't care what is the initial elongation. That's what I'm saying. We can skip that step. Let's say you push it by X further down. Now, when I draw the FBD, remember we are drawing FBD of change in forces. This is not a regular FBD. So when you pull this down, how much did the spring force change? Kx, right? Initially it was Ky, now it is Kx plus y. So the change is Kx. So this is a change in spring force. This is not the full spring force. Did mg change? Mg didn't change, so I'll not draw. That's it. Acceleration is downward. So we get Kx is equal to minus ma. A is equal to minus K by m into x. Done. So basically, I have ignored this step. It saved me time, isn't it? You have eliminated one step from it. I don't care what is the initial elongation because I know anyway it is going to get cancelled. Let me take one more example. This water container thing. So when you place it here, rho liquid, rho body here, right? It is already inside here. Let's say you push it by x further. So when you draw the FBD of this block, so it is already inside. I don't care about that. All that I'm interested is the additional buoyancy force. So this will be delta FB. This is that additional buoyant force. Because when you push only the buoyant force changes. And mg did not change. So we'll not write. That's what we do. So when you draw this FBD of change in forces, if something doesn't change, you'll not draw them. So we get delta FB is equal to acceleration is downward, always in the direction of x, just to get the minus sign. What is change in buoyant force? Rho liquid x L square g minus rho b L cube, that is the mass of the block, into acceleration. So we get A is equal to rho liquid L by rho Lg by rho b L into x. You get time period is equal to 2 pi root over rho body L by rho liquid x, rho liquid g. Same answer. This method saves you one step. That's it. You don't care what is the initial compression, initial elongation, initial depth. I don't care. All I'm that interested is when I displace it, whatever were initial forces, they will cancel out because it's already in equilibrium. So I will only take the change in forces. Is this making sense, everyone? This will save you a bit of a time. Check it out. Any doubts on this method? So remember this, we are going to use always this FBDs, change in forces FBDs. We'll not draw the regular FBDs anymore in SHM at least. And the whole reason it works is because initially it is in equilibrium, the initial forces cancel out. All clear? Let's see a question based on this. So let's say we have a container, liquid roll. We have a block here. This is a cuboidal density rho b, and we also have a spring here attached at the bottom. I did both. Find the time period for small oscillations. Again, why small oscillations? I don't want the block completely to go inside the liquid. If the block completely goes into the liquid, buoyancy force won't change, isn't it? So that is the reason small oscillations. Let's get this. I know answer is a little big. Try. I'll give another minute. Again, remember, we are not interested in the initial forces, only the change in forces. Assume the block is pushed inside by X. Find the change in spring force, find the change in bind force. What was the initial value? We don't care. What is the initial compression? We don't care. Because the whole thing is we know they're going to get cancelled. So works out. Let's see. It's a big one, I know. So there. So let's start like this. Let's displace this by X. So this is already inside by some amount here. Let this be the extra part here, X. So we get the additional buoyant force delta Fb, which is rho liquid XL square G. This is your change in buoyant force. Because when you push inside, it will increase. So the spring is also getting additional compression. So this is Kx. This is the extra spring force or change in spring force. So this right saves you time actually, or else initially by X everything lena padega, and they'll get cancelled anyway, so it's a waste of time. Done. MG didn't change, so I won't write. And acceleration. So we have delta Fp plus Kx is equal to mass into acceleration. Rho L square xg plus Kx mass will be rho B L cube into acceleration. So we get acceleration will be minus rho liquid L square G plus K by rho B L cube into X. If you see, the whole question was actually NLM and this thing. End mein SHM will come and say this is omega square. So that's what I'm saying. SHM is like that. The whole this thing is a different chapter completely. So this guy is rho B L cube by rho liquid L square G plus K. Is that clear, everyone? Easy? Any doubts on this? So there we can have a spring and liquid also together, they can act, so it works out. Next one. They were not convinced with this. Clear, na? Daksha? Ahana? Palak? Clear with this? Nikhil? Soham? Parth? Vihan? Clear? Next one. Combination of springs. This we already done 2 times. Once we have done in NLM, we did this also in elasticity, but let me show it again. So when do you say two springs are in series? If they have same force, or same tension. So if you have two springs, K1 and K2 in series, you can replace this with one spring, K equivalent, where 1 by K equivalent will be 1 by K1 plus 1 by K2. Be careful, this will be like opposite of resistors. K1, K2 by K1 plus K2. When they're in parallel, meaning they should have same elongation or compression. You can replace this as one spring K equivalent, which is K1 plus K2. What happens if you cut a spring? We have seen this. The spring constant K is given by Young's modulus area of cross section by length L. So K into L will remain constant when you cut it, because Y will not change, the material ka property. Thickness of the spring will not change. So if you have a spring constant K and L, and if you cut it L1 and L2, you will get two pieces. This will be K1 L1. This will be K2 L2, where the relation will be K into L will be K1 L1, K2 L2. Example, if you take a spring K and L, and if you cut it L by 4 and 3L by 4, this guy will be 4K L by 4. This guy will be 4K by 3. And this will be 3L by 4. The product must be K into L. Check it out. Series, parallel, and cutting of springs. This is important. So when you cut a spring, the spring constant actually increases. Clear with this. Any doubts on this? Let's see a question. Let's see a question. We have a spring here. We have one more spring here. This is M. This is K1. This is K2. This P is the point of intersection of both the springs. Find time period. That was easy. If the amplitude of the block is A, if the block oscillates with amplitude A, what is the amplitude of point P? So if the block is going up and down, then what is the amplitude of point P? You can find K equivalent, right? So if you can make them into one spring, you'll get that easily. Let's see. First thing I can find the K equivalent. That would be easy. K1, K2 by K1 plus K2. So we get time period is 2 pi root over M by K equivalent. It becomes one spring. That was fine. What about the amplitude? If the block is oscillating with amplitude A, then what is the amplitude of point P? Right, I'll give you a minute. नहीं वो just let's see. Think of like this. So what is same in both the springs? Since the springs are in series, isn't the tension same in both of them? So when this block M, this is K1 and this is K2. So if this is going down with A, so this will go down by X1, let this go down by X2. Make sense? There is no guarantee both will stretch the same amount. But I know x1 plus x2 will be equal to a. Do you agree? If the upper spring stretches 1 centimeter and the lower spring stretches 2 centimeters, then the block will go 3 centimeters, 1 plus 2. So x1 plus x2 is a. Second thing, since they're in series, they should have same tension. Since they have same tension, then I know k1 x1 is equal to k2 x2. So from here, if I substitute here x1, this will be k1 x1 by k2 is equal to a. From here, I get x1 will be k2 into amplitude by k1 plus k2. Now tell me one thing. Will this point P, right, if this is stretching, does P get affected? P will move only because of the upper spring, isn't it? If the upper spring is stretching x1, then P will also go x1 down. What the lower spring does has no effect on the upper spring. Is that making sense? So x1 is nothing but the amplitude of point P. बस वही करना था. Is that making sense, everyone? The point P will move because only of the upper spring. The lower spring, no matter how much it stretches, the point P is unaffected. So whatever is the stretching of the upper spring, that is the amplitude of the point P. Make sense? Any doubts on this? You can also say that k1 x1 k2 x2 is k equivalent, but why are you adding k1 x1 plus k2 x2?
So the forces of each spring would add up to.
They'll add up. Seriously. What are you talking? Think. So according to your logic, if this person gives this guy 100 rupees and this guy gives this person that 100 rupees, so total we give 200 rupees to that person. Then it is the same tension passing through an array. This whole thing is becoming one spring. The tension is same. You should have said like this: K equivalent into A is K1 x1 is equal to K2 x2.
Yes, sir.
The tension will be same. They'll not add up. Is this clear, everyone? Let's see one more. Find the time period. Yeah, you can just find the equivalent here. The springs are in parallel. So that will be 3K, 3K, 3K. That will be 9K. This will be 4K. This will be K. So we get 1 by K equivalent. Now they're in series. 1 by K. 1 by 4K plus 1 by 9K. This will be how much? 1 plus 1 by 4, 5 by 4 plus 1 by 9. 9 5 is 45. 49 by 36k. So time period will be 2 pi root over m by k equivalent. 49m by 36k. Yeah, it's a good square. You can take out 7 by 6 outside. So clear, everyone. 7 pi by 3 m by k. Easy. Series parallel. There's nothing there. Next one. Next one. You have a block m here. This is k1. This is k2 and this is k3. Now find the time period. See, another catch here is this. Most people, right, they think, see, one thing is clear. We know these are in parallel. Now the confusion is, what is this? They think it is in series. Now you need to ask yourself, let's displace this by x. So when you get confused, go back to the regular method. So what are the forces on the system now? If you displace this by x, this guy will push you by k2x. This guy will push you by k3x. This guy will pull by k1x. If you see, all the forces are in the same direction. Tell me one thing, what is same for all of them? Is the force same or is the elongation same? The elongation is same, right? So are they in series or parallel? They're in parallel, isn't it? आप ऐसा सोचो ना, think of like this. Instead of this wall, if I take this and put it here, does it make a difference? It would have been the same. So just because they're side by side, don't think they're in series. So k1 plus k2, all the springs are actually in parallel. X is equal to ma. Clear, everyone? Easy. Next one. So when you push it to the x, if you see, all the forces are acting in the same direction. So k1 is not in series. All three are in parallel. Suppose same question. Let's say we have a block M here, but this time you didn't connect the springs. This is k1, this is k2. The springs are very close, but they're not attached. What is the time period? Suppose same question, M, we have a spring here, k1, but on the right hand side, we have a rubber band. Instead of a spring, you kept a rubber band. Find the time period. What is the first one? What is the catch in the first one? Look at this. If I push it to the left, this spring will be disconnected. So this will behave as if there's only one spring here. So this part of the motion, the time period t1, is 2 pi root over m by k1. It will behave only as if the k1 spring is there. Similarly, when this thing comes to the right side, only this spring will act k2. So this will do this part of the motion where the time period is 2 pi root over m by k2. But since we can clearly see it is doing only half of each, the time period will be t1 by 2. So half of that one and half of this one, which is pi into root over m by k1 plus pi into root over m by k2. Is that making sense, everyone? So when you go to the left, only the k1 will act. When you go to the right, only k2 will act. So you're doing half of each. So finish it up. What about the D part? What if you have a rubber band? What is the difference between a spring and a rubber band? Think. That's a good one. I'll give you a minute or two. What is the catch? A rubber band can pull but cannot push, isn't it? So when you push it to the left, the rubber band is also there. So if you see, this guy is pushing with k1x and this guy is also pulling with k2x. So this will do half of the motion here, where the time period is 2 pi root over m by k1 plus k2. So when you're pulling it, rubber band behaves like a spring. But if you push it to the right hand side, the rubber band becomes slack. It becomes loose or slack. So basically there'll be no tension. That is a catch about a rubber band. It can pull, but it cannot push. So there's only one force here, k1x. So this will do half of the oscillation with t2, which is 2 pi root over m by k1. So it does half of each. So time period will be t1 by 2 plus t2 by 2. Clear, everyone? Any doubts on this? All got this? Next one. So that is the thing about rubber bands. I could have kept two rubber bands on both the sides, then the problem would look like C only. Isn't it? At any time, only one rubber band will act. So let's say we have a spring, mass M, time period was T1. Then what you did, this is cut into three pieces. And then you place them like this. And the time period became T2. Find T1 by T2. This is an easy one. Get it? So when you have a spring and a block, time period was T1. Then you cut it into three equal pieces and you kept them in parallel. New time period is T2. Find the ratio of T1 by T2. Hmm. So if I take this to be K, after cutting, this guy will be 3K each. So this will be 2 pi root over m by K. This will be 2 pi root over m by 9K. This is actually T1 by 3. The T1 by T2 is 3:1. Easy. So when you cut it, you made the spring constant 3 times. When you kept them in parallel, again it became 3 times. So it became total 9 times. Yeah. Right, everyone. Ahana, Ishana, Falak, Purvaja, Behan. Yeah, most of you got it. Next one. We have a block here. This is the mean position. X is equal to 0. You compress the spring here at x is equal to minus a, released from rest here. Basically, this is the extreme position. But then what you did, instead of letting it go all the way, you kept a wall here where e is equal to 1, and this thing was x is equal to a by 2. So technically, what should have happened? This should have gone till a and then should have come back, right? But before even going to a, there is a wall in the middle. You hit the wall. Find the time period. Now, remember, this is not a complete SHM. This is a part of an SHM. So if they ask you in the exam what kind of motion is this, you should say periodic motion. You should not say SHM. Because while hitting the wall, there are external forces other than restoring forces. So, but it is still a part of an SHM. So get this. The block is released from minus A. Technically, it should go till plus A. But even before going till plus A, it hits the wall and bounces back. Find the time period. Just give it a try and get some water and come. Any answers? Right, Porosa. Hana. Yeah. Yeah, two answers, everyone. Others try. I'll give you a minute more. Nee, Daksha. How did you get full time period? Let's see. So look at this thing. So this guy, when it is going, so it starts from here. So from here to here, I know it will take t by 4 time period. From here to here, I know it will take t by 6. Remember, a by 2? We did that in the last class. I should check it out in case you forgot. There, this is the time intervals I gave you. And I told you also how to figure it out. See, this is an easy way to figure it out. A by 2, meaning sine theta is half. Sine theta half, meaning theta is 30 degrees. Agreed? So for 360 degrees, if you take time t, sorry, this is t by 12, then 30 degrees will take t by 12, isn't it? For a full circle, if you take time t, then for 30 degrees will take t by 12. So a by 2 is t by 12. And when you come back again t by 12, remember there's no loss of energy because if you hit this with speed u, you're going to come back with u. We are neglecting the time interval of collision, and this is t by 4. So on the right hand side, instead of going t by 4, you only do t by 12. So you're done. So the time period will be t by 2 plus t by 6, which is 2t by 3. That will be 2 by 3 into time period is 2 by root over m by q. Make sense? Since it's a perfectly elastic collision, there's no loss of energy, so it'll always keep coming back. Any doubts on this? All these are easy ones, right? All these are mostly main cell questions. Next class, we will do actually the higher level ones. If you see all these, you're getting answer in 3-4 steps. Let's see one more. We have a spring and a block. System is at rest. Then what you did, you took another block of mass m, and then you attached at the bottom. And released. Now, if you attach at the bottom and release, suddenly the weight has increased. The system won't be at rest, right? Find the time period and the amplitude of oscillation. Gravity is there. Initially, system is at rest. When you attach one more block and leave it, because of the excess weight, it will start coming down, it will start oscillate. Find the time period, that is okay, and find the time period of oscillation. Get this, I'll give you 2-3 minutes. Amplitude, time period is easy. Right, Ishana, you got it. Yeah, one time period, now why are you guys spending omega? Yeah, let's see. So first thing, the moment you attach a block, the mass has become 2m. How do you find time period? Bring the system to rest at the new equilibrium position, then displace back. The story is the same, so it doesn't matter. The time period is directly T is equal to 2 pi root over mass ka placement 2m by k. Make sense? Now try to understand here. This is the natural length. This is the old mean position when it was initially equilibrium. And how much was this? This was mg by k. Now after attaching the block, this guy will start going down. Somewhere here, this is m and this is m. This will be the new mean position. Again, remember the mean position meaning net force must be 0. And this whole thing will be k into 2x, k into the new x mean is equal to mg. So this guy will be 2mg by k. Is that making sense? That's the new mean position. Now, let me ask you something. When you attach the block and left it, what was the velocity? When you attach the block and left it, what was the velocity? 0. This was at rest here. Now tell me, during SHM, at which position do you have 0 speed? Extreme position. That means for the new motion, the old mean position is the new extreme position. Is that making sense? The moment you attach the block there and you left it, it started from rest. That means that was the new extreme position and this was the new mean position. And that means this guy was the amplitude, which is mg by k. Done? Meaning if they ask you maximum elongation, then what will happen? This will stretch even further. I can calculate that also. So from the mean position, it will go further mg by k. This is the other extreme position. So in the exam, if they ask you find the maximum elongation, it is 3 mg by k. Is that making sense? Maximum elongation 3 mg by k. What is the maximum distance moved by the block? 2 mg by k from the initial position. What is the amplitude mg by k? So about this new mean position, it will oscillate with a on either side. Is this making sense, everyone? So the idea was this, because you started from rest, right? Since it started from rest, it must be a new extreme position. So in SHM, the point you have 0 velocity is extreme position. At rest, it is extreme. So the old mean position becomes the new extreme position. Is this clear, everyone? Got this? So these are all some basic, meaning standard questions. They're not tough. They're all like mains and bits level. The next class, when we catch up, we will do more higher level problems. We have more complex ones. But next class, we will focus more on springs and blocks. And then if time permits, we will also go for angular system ka little introduction. So we'll catch up again on Thursday. As usual, we'll continue from here. We'll do more problems. I think by next week, we should be able to wrap up the chapter. So make sure to go through this. We already did 18 questions, right? So any doubts, anything, you can stay back and ask, or else you're free to leave. I'll see you on Thursday at 5:30 as usual.